All right, welcome everyone. Welcome detectives. Today our lesson is called Detective Discriminant, cracking the case of the quadratic equation. So, you are about to be briefed on today's mission, okay? Imagine I'm handing you a confidential manila folder with all of the details inside. Your goal, can you solve the case today? Can you start to put the pieces together? I have full confidence that we will. So let's jump into it, shall we, detectives? So this is your mission briefing, okay? Today's mission, number 1, we need to learn what the heck the discriminant is. Objective 2, use this to figure out how many suspects are involved in today's mission. How many solutions a quadratic equation has, right? And lastly, become an absolute boss math detective, all right? We are out here in the streets and we are going to solve the puzzle. So here's the mystery, right? We have some cryptic clues left behind. We're looking around, we're looking through the evidence, we're sifting, and there's this quadratic equation. Now, I know, I don't really want to solve this. We have some strategies in our toolbox, what we've been working on. We could factor this equation. We could solve it with square roots. We could complete the square, but I don't need to solve it just yet. I just need to know how many people are involved in this particular incident right here, x squared plus 4x plus 4. How many solutions does it have without actually figuring out who? I need to narrow down how many people are involved. That's the objective. We're not going to solve it yet. That's coming soon later on in the week, but we just need to figure out how many people are involved with this, okay? So again, here's some information. Here's some intel to you. The discriminant will be used when we have a quadratic function in standard form, right? So it's been a minute since we've talked about standard form. Standard form is y equals ax squared. There's some number in front of x squared, that's a, plus bx plus c, right? We're going to use this discriminant formula, b squared minus 4 times a times c, in order to figure out how many people are involved, right? I'm not actually solving, I'm just putting together the puzzle pieces, right? And so the easiest way probably for us is going to be type it into Desmos directly as shown. When I mean directly as shown, I mean right over here. Okay, you can just type it in b squared minus parentheses for ac. I'm putting it in parentheses because it's 4 times a times c. And when we put things in parentheses, we know that means multiply, right? And then it's going to say add slider. Do you see how it says add slider right here? And you have b, a, c. You want to click the all of them. Okay, and then the sliders, kind of like our parabola project, are going to pop up, and you get to move this left and right however you feel. Or, I know you guys are not super huge fans of that, you can just directly edit right here and hand type in the values we have for A, B, and C. Okay, I'm going to recommend that because I know you guys are frustrated with the slider. Plus, we have an objective here. We need to find out as quickly as possible how many people are involved in this quadratic equation, okay? You also, if you really wanted to, you could evaluate it by using PEMDAS or plugging it into Desmos a little bit differently. It's kind of the same. So you would just want to put b squared, you want to put a parentheses around that b, just in case b is negative, minus 4, and then you might want to type in a times c like this, but honestly, I think we're going to use the sliders. So to each your own, but this is the objective. We are going to be using the discriminant to figure out how many people are involved, how many solutions are going on with our graph, okay? And so now I want to summarize and recap basically what we're looking for, right? We have an idea, but I want to give you a flow chart so you know exactly what we're getting into, all right? Here is the information you absolutely need to know. we're going to be figuring out the discriminant. The discriminant is right over here. If we have a discriminant that is larger than 0, it's a positive number, right? That means we're going to have 2 real solutions, right? So you can see the picture on the left. Here's a solution over here. Here's a solution over here, right? We're going to end up with 2 x-intercepts. If our discriminant is equal to 0, right, that means we're only going to have 1 real solution. And you can see that in our picture, that's right here. 1 solution, right? And if our discriminant is a negative number, if it's less than 0, we have no real solution, 0. What that's actually called is complex solutions, and it's a little too complex for us right now, so we're just going to move on. But do you see how this parabola does not touch the x-axis over here? There's 0 x-intercepts, or 0 solutions, or 0 zeros, right? So this is the vibe. We're going to evaluate our discriminant, and we're going to figure out how many suspects. Do we have 2 suspects? Do we have 1 suspect? Or do we have none? Maybe it was a ghost. I don't know. Let's hop into it, okay? So you can see what I'm talking about. So here's our first example. 5x squared plus 3x plus 1 is equal to 0. You can see my steps on the side, but first things first, I'm going to identify A, B, and C. A is in front of x squared, B is in front of x, and C is chilling off to the side. So I'm just going to be explicit. A is 5, B is 3, and C is 1. All right, so step 1, check. Step 2, I need to determine the discriminant. So in Desmos, we're going to type in b squared minus parentheses 4ac. So let's go ahead and split the screen right now. And let's get us some Desmos, right? So you're going to see firsthand how you type this in. So I'm going to go b squared minus, parentheses 4 AC, close the parentheses. Do you see how it says add slider? You're going to say yes. Yes, sir, I am, right? So now we have our discriminant, b squared minus 4ac. But remember that we said a was 5. So that's way down here. You could slide it around if you want. Or I'm just going to elect to delete. A was in the middle, so you have to be a little careful. B was 3. I'm just going to delete it and write 3. And C is 1, right? So you can see that in Desmos, 5 squared minus 4 times 5 times 1 is equal to negative 11. Negative 11. So let's go back to our intel, right? Negative. Right? Negative 11 is like a situation like this. So I already know the type of solutions. Since this is negative, that means I'm going to have no zeros or x-intercepts. Right? There are no people involved in this. I don't know. I don't have any leads as it is right now. It's a little complex. I'm going to have to do more investigation. I'm going to have to do more digging. So my graph is going to not at all touch the x-intercept. So that could be like this, right? Or it could be like this. As long as my graph does not, this would not be allowed because that's 2 solutions, right? As long as it does not touch, it's got to either float above or below. Any combination of this that you'd like, right? Any of these guys would be totally fine. But I know that there are no solutions. There are no suspect involved in this. Pretty straightforward and pretty easy peasy, am I right? Let's do another one. All right. 2x squared minus 6x plus 3 equals 0. Consider this your training on your on-site training. A is 2. B is negative 6. C is 3. Right? Identify A, B, C. Done. Step 2, determine the discriminant using Desmos. All right, let's go ahead and split our screen. Once we have this, dudes, we're ready to go. So we can change A to being, whoops, see how this got all weird? You can use the slider, but that's kind of frustrating personally. I'm just going to make A is 2, B is -6, C is +3. Boom. I found already that my discriminant is equal to 12. Okay, so now I got to figure out, all right, I found my discriminant, b squared minus 4ac is 12, right? That's 12, so that means this right here is positive. And when we were positive that we were right about this, that meant that there was going to be 2 solutions, 2 suspects. And so our graph can look like this. Actually, our graph is positive, so we might as well make it look like this, where we have 1 possible over here and 1 possible over here. I don't know exactly where the 2 solutions are. I don't know exactly where the 2 suspects are. Honestly, it could probably be like, not like that. It could be like this. It could be like this. It could be, until I actually solve, I won't know exactly how it's involved, right? But I do know that there will be 2 of them according to it being greater than 0, right? 12. That's something that's going to give me 2 real solutions. All right, one more. We got this, guys. X squared plus 6x plus 9 is equal to 0. All right, let's not waste any time, right? Time's a ticking. Here, there's nothing in front of x squared. That means a equals 1. There is one singular x squared, right? For B, it's 6, and for C, it is 9, right? You can see clearly that B is in the middle with the x term. C is the constant term, or the number, chilling on the outside. Now I'm ready to use Desmos to type this into B squared minus 4ac. Adjust those sliders to 1, 6, and 9. Right, I've already got them. So A is 1. Make sure you're only messing with A. B is +6. Oops. +6. And C is 9. We can see up here that my discriminant is equal to 0. All right, when it's equal to 0, right, we're talking about this, when it's equal to 0, that means I'm going to have 1 solution, 1 suspect. That means graphically, what that ends up looking like is that my graph only touches the x-axis once, like this. It could look like it, oops, that doesn't quite touch it. Maybe it looks like this, right? But it only touches the graph once. So you, detective, have this one to try for yourself. Go ahead, pause the video, and let me know what A, B, and C is, what you get for the discriminant, how many solutions this is, and double check and see if your sketch kind of looks like a possibility of what we might have. All right. Did you say A was 1, B was 6, and C was 5? Of course you did, because you're awesome. When you found the discriminant, when you plugged it in, did you get 16? B squared minus 4ac was 16. Of course you did. And since this is positive, that means we're going to have 2 real solutions, which means your graph could have looked like this, where there's 1, 2 solutions. Or it could have been negative as well, right? It could have been something like this. Either or works fine. Amazing. All right, one last one. Here you go. X squared equals 4x. X squared minus 4x plus 4 equals 0. Go ahead, identify ABC, figure out the discriminant, how many solutions would that be, and draw a quick sketch. Go. All right, did you say A was 1, B was -4, and C was +4? Of course you did. When you went ahead and plugged this into Desmos, B squared minus 4ac, did you get 0? Of course, there's no suspects in sight. We're going to have to do some more digging, right? If it's 0, that means there's only 1 real solution. So it's possible that your graph could look like this, where there's one solution. It's possible that your graph could look like this, where there's one real solution. It's possible that your graph could look like this, real skinny, right? But only one possible solution. Okay, you're ready to go on your mission. So your mission is going to be Delta Math 19. You have 2 skills you need to practice to make sure you've mastered it. Skill number 1 is exactly what we were just doing, using the value of the discriminant, figuring out that number, right? If it's positive, negative, or 0. Use Desmos to help you, okay? The tools are there for us. Skill number 2 is based off of a graph. Figure out what could be the possible value of the discriminant, okay? So this is kind of like when you have a suspect in a lineup and you have to figure out who could potentially fit into the puzzle here, right? Think like a crime scene. So, for example, I put some screenshots down here so you guys kind of see what skill 2 looks like, right? So based on this graph where it's floating above, what could be the discriminant, right? Is it going to be positive, negative, or 0, right? And if it's floating above, that guy is definitely a negative number, right? So if you see anything floating above, whether it's anywhere above or below, it's going to be a negative value. It could be -1, it could be -7, it could be -35. I don't know, right? But we're just thinking of the possibilities. Another graph might look like this, right? This guy's only touching it once. If it's only touching it once, you're going to go with 0. 0 and once. I don't know. It's kind of helpful. And same, if you see that it is crossing it twice, that's going to be a positive number. See how -10? That's negative. See how 0? Not going to be it, right? So use this to help you. It's going to be 0 here, not positive or negative. Here, this guy's going to be negative, not positive, not 0. Those are your type of situations. That right here, my friends, is skill number 2. So finish this ed puzzle and start your assignment, because guess what? It's due tonight, 11:59 p.m. You have plenty of time to get it done. So I'll see you in the next mission, y'all.